Hey everybody, my name is Gustav Reitstedt. I'm here to talk about frame busting today. Pretty exciting stuff. Hope you guys not too tired just before lunch like this. I'm currently a student at Stanford University, and I'm with the web security lab there. And they sort of just tell me what to do, and I do it. And this time they told me to look into frame busting. Weak reference there, but this is joint work with Ellie Burstein, Dan Bonet, and Colin Jackson. Colin is at Carnegie Mellon. So I just wanted to get a show of hands. Who knows what frame busting is here? Yeah, I'm guessing a lot of people here do, but I'm just going to show you quickly what it is. So the idea is that you're framing someone in an iframe that doesn't want to be framed. So this is Google in my iframe. They do not want to be framed, right? Because there's some issues. For those who were in the talk right there, that you know that there are some issues with being framed, but I'll cover some of them really quickly. Frame busting are techniques to get out of a frame. So I'm Googled right here, and I don't like that some bad guy, Gustav, is trying to frame me. So I jump out of my frame, and I get to be top context of the browser. That's what frame busting is. It's pretty simple. We'll look at code. This is what a pretty normal frame busting code looks like. It's a conditional statement and a counteraction. We check if we are top. If we're not top, we want to become top. And there are several ways of doing this. This is a pretty common little snippet that does it. So why do we want to frame bust? There are several reasons. Probably the primary reason is clickjacking. It was this cool attack by Jeremiah and Arsenic back in 2008, and it showed that you can take this cool-looking game right here, right? I'm controlling this game page right here, and here this is a transparent iframe that I put on top. And then when someone actually clicks the play button, they're not clicking on the play button, they're clicking through the transparent iframe into, it says something, I don't know, it says, okay, fine, deactivate my account for Twitter. So you went on this page and there's this cool little game, and I'm thinking, oh, I'm gonna play this cool game someone sent me, but you're actually deactivating your session-based Twitter account. Just recently, Paul Stone at Black Hat came up with this other idea that you can actually utilize drag and drop to extract and plant data into this framed page. And this is, I think we're just seeing the beginning of this. You can get the source code of a framed page. You can get CSRF tokens. All kind of leakage can happen. And it also, it was covered there just briefly, but you can actually use these URL fragment identifiers to do some pretty severe leaking based on how much your page scrolls. And you can dynamically read how much the page scrolls, and then infer some information from that. I'm not going to cover a ton of it, but you'll see some examples. So our survey idea was we look at Alexa Top 500 and all US banks. We'll grab all their frame busting code, and we'll look and see, is it safe? Is there some sort of standard practice that people use? And can we improve on it? We use this semi-automated tool based on HTML unit. It's a JavaScript emulator. It wasn't that helpful, so actually a lot of manual work. The biggest reason being that a lot of pages out there look like this. It's kind of a nightmare trying to find frame busting code in there, and then they have all these packing things that structured things very strangely. And it took some work, but it took about a week, and we found all the frame busting code of the top 500 sites, and these are the results. Top 10, 6 out of top 10 pages use frame busting, 37% out of top 100, and 14% of the top 500 sites. And this, we were guessing that it was low. 14% could be considered low. But what was sort of more frightening was the lack of a sort of standard of doing this. You think that they've sort of, these are the top sites of the internet, they know what, how to do this, but they don't. These are sort of conditional statements that we saw, lots of different variants, and the counteractions were even worse. Lots of different things, most of them broken. There's just sort of frightening to see that nobody really knows what to do. And I don't really recommend doing this top 500 site crawling thing. It's sort of traumatizing and deeply scarring inside. You visit lots of pages you would never want to visit, lots of languages that you don't understand, and if you're a security savvy person, it's even more traumatizing. But I figured we'd go through some of the things that we found, and sadly enough, all the frame-busting code we found on the top 500 sites were all broken in many different ways in several browsers. The best one was actually Twitter. I'll show you how to break that. Well, first we'll check out some site-specific, poorly written frame-busting code. And this is we'll make it a game. You guys can look at it and tell me how to break it, and you get like an extra cookie at lunch or something. So this is courtesy of Walmart. They do if top.location is not equal to the location, and then they check for the refer, and they do document.refer index of walmart.com equal to -1. So they do some substring search. What's terribly broken about this? Just shout it out. Who? What? Yes, there's several ways of getting walmart.com into your URL that you're framing from, so this is very, very broken. Let's move on. New York Times, they have this cute little regular expression that they use .match with. Any regular expression gurus that can see what's up with this code? It's not anchored at the beginning. You get like lots of cookies. So we put it in the URL parameter HTTPS New York Times, and we can frame New York Times. You have all your news in a frame or something. Cute. U.S. Bank. They actually, this is only a very small snippet of their code. Their whole entire frame busting code is something like 200 lines of code. It's very advanced and doesn't do very much. They do this get domain, it's their own function, and they pull out the domain of the refer, and then they do this search with this regular expression. What is wrong with this? It's going to go on. So, US Bank do not own all subdomains in the world, unfortunately. So you can just have usbank.attacker.com, or perhaps they have some sort of strategic relationship with the Norwegian State House Bank, husbanken.no, I don't know. Or rusbank.org, possibly. I don't know why they have this code. It's not very safe, and they threaten you in all kind of ways that they will contact your ISP when you frame them, and I got lots of threatening emails, but I don't know, it's terrible. This is MySpace. They have this very nice little refer match with, they want to allow lots of sites. I've highlighted the one that's interesting, which is Google's image results site. So they allow image results to frame their profiles. So why is this a problem? So what does image results look like? I'm sure you've all seen them. They're pretty much framed pages, right? The problem is Google's image results do not frame bust. So we can actually just make we can craft a specific URL and get a very specific profile, and then we just frame Google Images, and we're in the clear. So, just a word about refer. Refer is kind of funky stuff. There's been many, many attacks on the refer attribute because of affiliate scamming and so on. You can also do some open redirect refer changing, HTTPS to HTTP washing. Some people don't know about that. And obviously it can get hard with regular expressions. as we saw, and your friends cannot be trusted. And another thing is that some sites do not know, they sort of assume that the refer header is always there. This is a very bad assumption. It should not be made. Refers are often stripped by proxies, or they're stripped by something like the HTTPS, the HTTP washing. So if you're going to use the refer, do it with caution and sort of know the implications of it. So this is Facebook's dark layer defense. This is the clickjacking defense that they deployed in, I think it was March or something. I used to think this was a pretty cute idea. I don't anymore. What they do is when they notice that they are in a framed context, they put this huge black transparent layer over the entire page. So any clicks that you try to make that go straight into Facebook's page, they will go into their div and they will just die off. And actually, when you click it, they will try to frame bust. So we'll look at their code. This is what their code looks like. You don't really ignore the stuff on top. They do this, they put this big div. It's 9,999 pixels wide, and the height is the same, I think, yeah. And they have the Z index of some 1,000,001. Now, what's wrong with this? Any idea? So is 9,999 the biggest div you can ever make in HTML? No, it's not. You can make it bigger. So you just make it an iframe that's 3 times as big. And the bad thing about Facebook's content is that it's floating. So it just floats out of the view, and it gets sort of, it just gets out of this big div that they put on there. And we actually told them about this and several other attacks. And the night after I first presented this, they were hit by some Czech guy that, I don't know, I think it was 800,000 accounts or something were hit by this particular attack. And then from there, there's been sort of an escalation of like jacking and whatever it is, boob jacking, I don't know, all kind of crazy stuff that Facebook is under attack right now. So it's a severe problem that they're dealing with. Now they fixed this problem, but there's still a lot of issues here. For example, the big black div still renders all the session-based content. So your scroll bars will actually expand as much as your profile page allows. So you can do all the fragment identifier-based attacks and all the frame leakage attacks still. This does not stop that. That's why I think this is not a very good idea. So I can figure out if you're logged in, I can figure out who you are on Facebook, I can figure out who your friends are. And they do not stop it. So let's check out some of our generic browser weaponry for attacking frame busting. So this is a code used by a lot of people. If top.location not equals self.location, then parent.location equals self.location. Any clues why this is a bad idea? Someone said one. Right, so what would happen if there are several? Would they go up? If I have 3 iframes on top of each other and this is the bottom one, would it recursively walk up? No, it wouldn't. Maybe that's what they're thinking what would happen. That's unfortunately not the case. So if you enclose this in 2 frames, you're actually battling the descent policy that was, it's in all browsers now, I think. It was proposed by Adam Barth, Colin Jackson, and John Mitchell back in 2009. And it's part of what makes your pop-up blocker work, and also some very funky frame navigation stuff that we don't want to allow. So top.location equals self.location is just an allowed special case in this descendant policy. So you can actually not navigate your parent if it's not the top. So people who write this kind of code, they just don't, either they didn't know or